everybody, and welcome back to a new episode of the TypeScript Tea Time. I'm your host Mirko and hope you're having an awesome day today. This is going to be a relaxed after work chill stream, just a bit of coding, having a good time, a bit of chatting, and that's what we're going to do. And to start our relaxed after work day, we're going to add a death ray to our game. Maybe not the best start for relaxation, but death rays are cool. So you might see that this is now using, so I'm in our T-Wars front end. You might see that I'm actually using Vite now, because we were able to switch to Vite the other day. We had some difficulties with that. First, in particular, the front end decided that, well, Socket.io version 2 does not really work with Vite, or at least not with Vite 3. So what I did is actually go into the back end, upgrade everything to NestJS 8, and most importantly also upgrade NestJS platform Socket.io to version 8, which now uses Socket.io version 4, and thus I was able to upgrade the front end as well. But to do that, I actually had to get rid of Goose. We don't have in our project anymore, we are just using regular NestJS Mongoose now. Yeah, so we have Mongoose now, we have NestJS 8, we have Socket.io 4, and on the front end we have Vite. Yay! And indeed, it is way faster, like way faster than our original. What was it? I'm not even sure whether we used Webpack 4 or whether it was 3. We definitely did not use Webpack. So this is our little game. Oh. Our enemy is not in a good mood. He's all red. So this is basically a Final Fantasy that can be controlled from Twitch chat by putting in specific commands. Currently I'm in development mode, so you won't be able to do any of those commands, but typically we would be able to add a new adventure app by joining. We can start attacking, so we can receive damage like so, we can actually die. Oh no, that didn't work. We can cast heal. He can still cast heal, but because it just calls it directly on the object. The backend handles all the stuff that is about the logic. So who attacks whom? Can somebody attack? Can somebody do an action? Or is somebody already dead and cannot do anything anymore? So normally the front end would not be able to receive any of these commands when you're already dead, but in this case, because it's not linked up to a backend, it does work indeed. What else do we have? We have a couple of, well, we have just the basic attacks. Some of these friends even have animations by now. This one. But it's very, very rough for me to draw all of these animations. The original characters are open source, and you can find all of those. I think they have judgment. Yeah. The characters. So most of it is from Open Game Art. Where are the actual people? It's got enemies. Yeah, we have a lot of enemies, in fact. So the background, which character you actually get, we have like 24 or 22 different characters. Some of them have at least idle animations. This one has even an attack animation. And we have like 200 different enemies, I think. All of them coming from the end. Somewhere in here we should man wizard. Probably looking at the monster, right? Should be somewhere in here. Yeah, the backgrounds, animations 1 to 8. Let me show what that one is. Thirds. At the very least, they are CC0. And they are from OpenGame. I can immediately find them. Yeah, what else can we do? We can cast fire. Can cast ice magic. And we can, at least I can already kind of click the button, cast our Death Ray. Death Ray on a nice after work stream. Isn't it relaxing to have a Death Ray? It's good. Can also level up. Yay! Reach level 99. Wow, that was fast. So that's basically the stuff on the front end. I think what we need to do is go back into the back end now and link up so that we can actually call the lightning strike magic. So in the front end, well, let's do the part that we do in the front end and then link it up with the back end. Somewhere in here we have cast lightning apparently. There it is. Edit that one. Interested in seeing API usage. How about no? No. Thank you. Wonder who that was. Is that a new feature from VS Code, or was that part of Copilot? So where is it again? Cast lightning. There it is. On there. So to do, we have to add the backend. Basically, what this does is it plays some SFX. It else adds this sprite, and it plays the animation for the sprite. Apparently, it's a sprite sheet thing. It looks like this, and I guess I'm using this one and then just rotating it in the right direction. Because if you, for example, Amazing Ventura 1 does the lightning call, lightning strike, it maps or connects the caster with the monster always. So there's a bit of this diffx, for example, insider there as well, to actually hit the right person. This one has to be linked up first of all to socket.io. That's done in the main scene. Main scene turn on. Main scene turn on. And in here we have our create method, which is the first thing that. So first of all, some phaser basics. You're new to phaser, version 3 in this case. You typically work with so-called scenes. You extend the scene and then you start a scene at somewhere. And then what automatically happens is that this create method gets first called. There you basically do the setup stuff instead of in the constructor. It's slightly different from what you would typically do in JavaScript or TypeScript. And after that we have, I guess, an update method, which runs every frame, 1/60th of a second, 60 times per second, and then from there this automatically gets called by the framework phaser, and then you call the individual update methods of your sprites and whatnot, or can do other stuff that you have to do every frame, like check for collisions if you want to build your own collision, but you can also just use phaser. We typically rely on phaser. In this case, since everything is event driven, but from the backend, from a socket connection, what we do is we initiate the socket.io connection here, And you see this is using the new Vite syntax here to get the environment variables essentially. And we just listen to the initial events and then append everything to a kind of log file and then render as soon as we get something with this handle event function. For example, we have events that make a monster appear. That all of the logic happens on the backend, on the server side, and it doesn't render it. Sends it to the front end, or to any front end, there could be multiple. And the front end decides how to actually render that depending on the event. For example, here in the monster event, we add a new monster, depending on like, what is the monster, how long it will take, and similarly for adventurers to join, how they attack, and all of that fun stuff. We also have ice cast and fire cast inside of here. So what I want to do, I guess, is just copy this. I don't have lightning in here yet, right? Create the animation frames, but that's it. Yeah. So which one did I copy? This one. Here I want to say lightning cast. It does not exist as a type yet, but other than that, this looks fairly promising, except that we have to use cast lightning of the monster center, which is a function that is provided by Phaser. Whenever you have an image or sprite, you can just take the center or the top left or the top right or the top center and so on and so on. Now we have to just add this event there. Somewhere we have ice cast. Can just copy that one, call it lightning cast into the string, and target and actor is exactly what we want. So we get the adventurer who casts lightning, given the event.actor, which is the username, and if we find him, normally the backend should only give us the stuff that we really want, or that actually exists already. Then this adventurer casts lightning onto the monster. That's it. And I suppose, yeah, I give it just a point. That's why we use getSendA. You're not happy yet because I have to add this up. So, and now we're good. Yeah, everything is happy. So front end is prepared to actually cast lightning. Actually, kind of work in progress. Yeah, I guess we can. Let's call it prep TWAS first of all. I think typically we used our episode number, which is by now 89. I guess we just call it the context because it's a kind of monorepo for all the stuff that we do on stream here. For most stuff. TWAS prep front end for lightning blitz magic. Right. So front end is done. Go into the back end, and here comes now the fun part. Have to add the ability to listen for the chat message. So what we want to do is listen for chat message that says something like exclamation mark lightning, or exclamation mark bolt, or exclamation mark thunder, or exclamation mark else blitz, exclamation mark. Did I write those down already? I never remember that I did that. I didn't. At least not here. Alright. Or did I put it in the death array? Yes. If you have any other words that you want to add, Pivers, hey, how you doing? I wrote the article on the JS challenge you have related me. The backlink to oh, thank you so much. Very generous, and congratulations on publishing the article. Hey, hope it gets received well. It was a very nice challenge. I didn't get it until Homeless pointed out. Nice, look at that. Yeah, check that out, everybody. Very nice. And first, try to take the challenge if you're up for it. It's kind of a security question. What will this code here log into the console? And then, yeah, try to figure out what it will do. It's the first one, no traffic really, and posted it. Ah, very nice. Oh, you're on Twitter. If you'd like to share it on Twitter, you always just at Pilfer. Will probably follow as well. Binary Goblin. That's a great name. You're playing D&D or any of those? I invented bad code. Yeah, that's how it happens. Very nice. Yeah, follow me. It's 2012. It was in the cradle of Twitter, wasn't it? Let's see. I would like vote. Check out this. And I'm just writing a message and check out that we validate on it's and join it at binary public. Oops. There you go. Sorry, when I'm writing something, I cannot really talk. And I additionally do not see the Twitch chat right now. Yeah, I got that from my father. Basically, when he was like, we could talk to him at the kitchen table when we children got ready for school. We could basically talk to him, and he was reading. And after like 20 minutes that we kind of talked to him and talked to each other and talked to him again, he was like, what? Looked up and didn't hear anything. We're still making fun of that right now, us children. Is it stream chop for anyone else? Oh no, is it? Maybe I should take this one slightly closer. The music is fine, just the voice. Oh, okay. Yeah, thank you for the notion, for notifying me there. Wasn't even aware of that. All right. Yeah, let's keep close to the microphone. That's always a good idea when you're on stream. Thanks. And thanks for the article again, and also for posting the challenge to us. Very nice. I will save that for later. I think I have it on Twitter now, so that I can read it in full. In here, If you have any other words for like lightning or blitz magic or bolt magic, yeah, sure, you're absolutely welcome. Then please let me know. For now, I have these, and we will now make them, add them to our stream, so that we can use blitz magic, like so. Death ray, more death ray, even more death ray. So to do that, we have to listen for the chat message, and they. Not sure how I do this with fire, but I suppose we can do it similarly. Then make the adventurer cast lightning and send an event via WebSockets. This will basically happen automatically if we just call one specific method. But that's basically the way that we do this. I suppose we already have like fire inside of here. Message includes fire. We just use exclamation mark fire. Okay. I want to have, I think I called it lightning now. Exclamation mark lightning. And let's give it these just alternative names. So for example, attack, so that it is less annoying or less boring. It's rare. It's more exciting. You can actually use exclamation mark attack to attack, but you can also do strike, or you can hit, or you can charge, or you can assault, to do a regular attack with just your melee, essentially. So we have, what did I say? I think I said bold. We have number 2, which is thunder magic, or we have 3. Let's, yeah, so those 3 here. Then we can basically take the pattern that we have inside of attack aliases, yeah, okay? Wow, I made it so complicated. On lightning aliases. And dot lightning 1, or lightning 1, 2, and lightning 3. Let's. If lightning aliases dot sum command dot includes, no, message dot includes this command, message dot includes command, then we want to do something. Hey, is that an I or is it an L?
Lambo joined our tea time.
Jambo? Is it an L or is it an I? It's an L. Hey, welcome to the stream. Welcome to the TypeScript Tea Time. I'm Mirko. Glad to see you. Here's your drink. Take a sip. Lean back, we're doing phaser development. Well, we kind of already finished the phaser part. We are adding death rays. Yeah, death rays. Death metal rays. Maybe we should call them death metal rays. So this dot battle dot, oh no, don't do that. Cast lightning of username. We only have one monster, so it's clear who to attack. Why do you complain? Because you wanted the space right there. Okay, that's fine. Now we need to add this method, and then we can jump right in. Somewhere we already have cast fire, cast ice. These are very, very similar to each other. Maybe at some point we will like make it more data driven. I don't know how you would generalize, so that we can directly call cast lightning on the adventurer. So what does this do? I basically just copied because it's pretty much identical to when we cast ice. We get ourselves the adventurer by the username. We then check whether, well, if we have we ensure that we actually have an adventurer. Somebody could not have joined the stream, could not have joined the battle from Twitch stream. So it's just chatting and still writing a message. In that case, we do not have an adventurer. That person did not join the battle, so they cannot cast any magic in this case. They would first have to join the battle. And well, then if this adventurer was found, he should call, or he or she should cast lightning. Inside of there, we're also doing the check whether you can actually call lightning. Maybe if you're already dead, your HP is 0 or minus, then you would probably, or you already did an attack this round, then you're not allowed to cast this, but this is already handled. And we're just calling. If the monster is already dead, then end the battle. Is this actually idempotent? Yeah, it's idempotent. Very good. All right. Because this might be called multiple times. If people write many messages after another, and the first or the second message maybe kills the monster, the messages after that will still be triggering this, and they would still trigger this call, so it's important that this end battle function is idempotent. Oh, I'm not even sure whether it will trigger the battle, because the battle is over then. We'll see. It won't cause trouble, definitely, if it's idempotent. Let's call it say it like that. Let's add this function. Ramps, jump right in there. And somewhere down here we have heal, egg, party, receive heal. There's a cast. Cast ice. Cast lightning. Public. So, first of all, we check whether we can still act. If not, we stop. We don't do anything. Then we do a damage roll. Well, we just roll a random number, which includes 0, I think. I always forget this, and it includes also 19. Let's take it. And then plus your current level. So when you level up, because you can actually level up in this game over multiple streams, most likely when we actually play, you will get stronger. Currently, it's very, very simple to get stronger, or the math in which way you get stronger. At some point, I don't know, I think about equipment maybe, and items maybe that you can use, or I don't know, maybe like skill points that you can use to for example unlock ice magic or stronger ice magic maybe, and so on. So that would be fun. So here comes the fun part. We push something into the log, and that's the part where we do which actually gets then sent to the front end via WebSockets. We have that hooked up automatically. So in this case, it's just a lightning cast. The actor. We do not get type completion at this point because I do not have it set up as an event on the backend yet. I'm not sharing any code between frontend and backend, which I put lightning cast. So we have to kind of duplicate this code from time to time. It's basically only just the events. But I'm fine with that. We need to rename this function, of course, this interface to lightning cast. And save, and also add it up here, which I did already. Very good. And now we should get auto completion right. So this is the username, and yeah, there we go. TypeScript is as clever as limiting down what kind of event we're actually having, even though this is an I event. And an I event could be a damage received event, an attacked event, and a joined event, and they might look different. Or, for example, this receive protect cast does not have an actor. So TypeScript is clever enough by using this the specific type, the type. So the property type of the TypeScript type of the property type. Man, that's so complicated to say. To narrow down what kind of event we're actually dealing with. And in this case, is it? Yeah, it immediately knows that we're dealing with a lightning cast event. So it can say, oh, you have lightning cast.target, which is a string, which is monster.name. Save. Should be happy. Yeah. We also have to set that you cannot attack twice, or act twice in this case, and the monster should take some damage given the damage number. Yeah. Alright, and that should be it. That should be all there's to it. Basically just copy and paste it and added lightning cast right there. It wasn't too hard, I don't think. So, wanna test it out? We need to run the server. Important. Otherwise nothing will happen. Eat. Exclamation mark lightning. He was eat exclamation mark lightning or electricity. Oh yeah, that's enough. Electricity. I don't know. Exclamation mark lightning. So let's reload this one. I think let's go into main scene here just for a second. We disable the death mode for now. Now we see an empty stadium, basically, an empty scene, and we should see that we do requests there. There could be a lot of optimization here, but yeah, there we go. We're doing requests to the backend, and now we're talking over WebSockets. And from here on, I can do exclamation mark ambush to have a monster appear, and then we can start joining. There we go. I'm almost dead, in fact. And we can start exclamation mark lightning. That's where the start. The battle only really starts after. Oh wow! Hey, it works. See that? And I also have like exclamation mark blitz, right? My HP are very low. We do not handle the case where somebody is moving away, but I think that's okay. What else did we have? Blitz, lightning, forward. What actually happens if I do this? I think it would just take the first. So I'm now. Oh, I'm dead. Am I? No. Okay, great. Right. It works. It just takes the first match it has. That is because, so that works. I can revert that one. Why does it only take the first one? Because inside of here, in the chatbot where we handle the messages, we always check whether a command is included, and then we return and do something to do it. So none of the other codes, none of this other code will run. In this case, my exclamation mark eyes, sorry, exclamation mark fire, exclamation mark bold, exclamation mark eyes. It first matched this one, even though it also would match this one and this one. In here, it immediately returned, so there was nothing else to do. There was an interesting library just recently. Oh no, I'm dead. I hope I'm not dead for good. It was called TS match. No. This one? No. This one? TS pattern. That's it. TS pattern. And that would actually help us here, I think. Match result with this one, and then call this function with this one, and then call that function. Dot, 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 dot. So that would be interesting to use, just to have it used once. So pattern matching is very, very common in like more functional programming languages. I've written some COG. I won't pronounce it. And there you had to, which is basically a programming language for math, proving stuff in math. So. Language. One. That one. Python. No, that's also not. Proof language. Yeah, I think that's it. Yeah, that's it. That's a product. I've written a bit of code inside of that. If you're a mathematician, that's very, very useful, because you can basically prove mathematically but using algorithms. And it's written in a way that it actually works, and people acknowledge that stuff with proven with cog is indeed working. Oh, it's COQ. I didn't know that. Also, I thought it was a... Well, anyway. And there were a couple of proofs even. I think the 4-color theorem or something. Is that it? Color theorem. Proof. Yeah, I think here it is. Yeah. The 4-color theorem was actually proven with the help of COQ. Writing a formal proof. So there was quite some news that actually works. Math stuff. So, and pattern matching is very, very common in these kind of languages. So we could try to do something like this instead of having like a million if conditions. Yeah. Although it doesn't quite work, huh? But actually working the way I think. Oh, apparently Swift is also using it. And Rust. Oh, I didn't know. Oh, there's even a proposal to add it to ECMAScript. Interesting. Still in stage 1. Okay, that's far from far from actual production and adding it. So what can we do with it? We have a couple of states, for example. Oh, this is exactly what we're doing on the front end, right? When we receive the message, like here. This is like exactly what we're doing. Not sure whether this is actually more readable to me. No, to be honest. To be perfectly frank. It would be interesting to try though. Example, a state reducer with TS patterns. Then you have as the callback function the function that turns. What does .exhaustive do? Executes the pattern matching expression and returns the result. So we don't forget any possible cases. Oh, interesting. That would be something that we could try. Let me just write this commit message. Apparently was 3. Oh, these are new. Those yet. I think this one was always just on in another place, right? This one, yeah, they added the commit graph, which was a default feature, by the way, on GitHub, but they removed it, and I hate that they did that. You could just click, I think, on the forks or somewhere, and then you immediately saw this graph here. Come on, you can do it. Come on, you can do it. Doesn't it work? Maybe you need to be logged in, because here it's loading. Ah, no, it's loading. Okay. So in this case, you immediately see who forked where and when and the complete history. Which was a very nice feature if you work together with other people. There's even a better, I like the version from GitLab, I think. That one was really, really good compared to this one. Hard to use. And pretty much we have the same here, just that it looks slightly nicer. Probably they copied it from GitKraken, which belongs to GitLens. All right. Magic is working, or our death ray is actually working. That's very nice. I think we need to build to actually have it. All right, build done. And it was so fast compared to the 20 seconds, but yeah. Let's just for fun try to use TS pattern. I want to see what it can do. Let's just for fun. Do I want to use it on the front end or on the back end? That's the question. So pattern match on any data structure, nested objects, arrays, tuples, sets, maps, and all primitives. Type safe with help for type inference. Exhaustive if checks. Enforcing that you are matching every possible case with .exhaustive. Ah, that's what it's doing. Okay. Use patterns to validate the shape of your data with is matching with the API with catch-all and type-specific wildcards. Can we actually use it? I mean, we can use it definitely on these ones, right? It will get more complicated in these cases, but it should still work, right? Here, this might be more complicated. Let's try it. And I say we try it on the backend. So we do npm. Am I using yarn or am I using npm? npm apparently. npm install. And this is ts minus pattern. That's how it's on npm. Yes, very good. Yeah. All right. Next, where did my code go? So in here, we want to have match result. Well, we take these. Result a data, and then we have a const result. Then we start matching it. So, oh, but we have to use includes. So that's not quite pattern matching, right? We have something like includes? Oh no. What does is matching do? Contain. And this can be objects containing subpatterns. An object pattern will match if and only if the input value is an object, contains all properties the pattern defines, and each property matches the corresponding subpattern. Of name. We don't really have those. Maybe we need to go on the backend and they're on the front end, sorry. Although here they it contains one and hello. So maybe we start using it on the... Alright, I get it. Let's remove you again. Bye. Instead we use npm install pattern. These checks here everywhere. We can remove them, right? Yes. So we have an input. Let's start at the very top. Just the most basic of could handle event. There we go. So we want to match event dot exhaustive. Yeah, do it. And do we already Find the pattern matching expression and returns the result value. So dot with. What do we take? So we have type, for example, join or monster here. Let's start there. Then we want to call this dot add monster of event. Right? That how it works? Why do we not have event here? We can get the... okay, there we go. So up here we put in an I event, we say with and the pattern that it should match, and then in the second part we can say what should happen, and we get the event again as its parameter, but this time it's correctly typed. Which also happens if you do an if. So these two are now identical. This line and this line. Let's continue, just for the lols. In this case, we want to have type join. If we get that one, we want to have a function which again takes e, the event, and then this time it's a function that does e dot blah. There we go. That's the second one. Handled. Then dot width. Oh, this is starting to get fun. This one is more complicated. This one is more complicated. Problem being the is monster, whether the monster is there. Check. I think what we can do, here's my guess, we can do something like this, comma, is monster false. So this is what it should check. Is monster terrible? Was a terrible idea, to be honest. The actor would be much more interesting, I think. And then we call again this fun stuff. Problem being that we need if not this dot monster, then return, and we need the event again, which is typed to target, attacker, and is monster and type. In other words, it even narrowed it down. Interesting. So the attack event, I think, is attacked. Yeah, the attack event would be is basically the attacked event, but sorry, this one. But additionally, is monster is always false in this case. So very good. We can do the same with type attack is monster is monster true in this case. We do again have to move the if not is monster return check here, however. That one is becoming a bit annoying right now. There we go. this into a one-liner. Is that an option? Yeah. That's better. This is not terrible. We can just look at the if at the width to see the ifs basically. Basically any if statement. Dot with. So let's maybe take 1 second here. Think about whether how can we make sure, because this this dot monster will appear in all of these basically. Pretty much. Or at least in many. I guess we, yeah, let's just leave it as is. Width. So type is damage received, and that's it. Then we take E and we map it to this dot on impact, on attack impact E dot damage. Next dot width. Interesting. I'm curious how this will turn out. I mean, we're basically just having an alternative way to write a switch or many if statements with nice type checking, but the type checking was great before that as well. So I'm curious whether in a month or so we will say, wow, this is amazing. TS pattern is the best thing that we've ever had. Or whether we will say, well, it is not really extensible. I'm very interested. So that's the library we're currently using. Apparently, I think on Twitter, the creator said something like, "Oh my goodness, we have so many stars by now," and it was basically just a 5-minute or a project on the sidelines that was not even really thinking about. But now it became this kind of project, which is, I'm not sure whether I should be happy for them or not. 3,900 stars. I mean, of course, I'm happy for them in the sense of, wow, you created something that people want. The problem with this is, well, they're not getting paid, right? Most likely. So there might be a chance that this will be a project at some point that they cannot really use anymore. Oh, be aware you have to use strict mode, which we do. 4.2 and 4.1, or actually all the 4 point something are not supported. Interesting. Interesting. I wonder why. What else do we have? We have type, attack. So have you friends worked with any of these libraries or with pattern matching in any language? I've seen now that apparently it's stated here somewhere that it also in Swift and Rust. That's the thing. I only knew it from like something like functional programming stuff, Haskell, Elixir. I'm not even sure. Dynamic functional language. Okay, yeah. They have a nice logo. That's a nice logo. I like violet or purple color. Is monster true? Then we want E maps to. If not, it's not monster. Turn. Otherwise, take all of. Oh no, where did it go? Don't scroll rapidly. All of this and put it right there. And also say instead of event dot, say e dot, which is correctly typed now. Why do we even have the? We probably want to move these. Wait, something is wrong. We have type attack is monster true, and we have type attack is monster true. That's not right. Something is wrong. We have the same if condition twice. And now we can easily see that, right? Now we can easily see that. While earlier it was more obscure, or was it really obscure? I don't know. Not. So here we have attack monster false. Ah. Where did this one come from? Did I already copy all the code from down here? No, that's different. Where does this code come from? I think I made a mistake on that one. That's the monster attack. So here the adventurer attacks, which is of course wrong, right? So I think what we want is this one and move it up there. So now it's a monster attack. Then we don't need this duplicate one. Done. Correct. Very good. I was just, I made a mistake apparently. Next one. Type. Firecast. Auto-completion. We take the event and we say if not this.monster, then return, otherwise do stuff. Monster not this.monster, return, otherwise do all of this fun stuff. And actually cast fire. Next, with type ice cast first, and that's it. E maps to, and we take our monster check. Maybe there's a way, but I don't know yet, to make TS pattern also recognize or add the existence of the monster in here. Might be able to do that. I don't know if we add another one here. Is that monster? Oh, that one is. We could make another. I mean, we could also always do something like this, right? Monster or monster existence is monster. That's always possible, but then our matching would be bloated, and I don't want that. So for now we will just go with this one. Maybe I have a better idea at some point. Probably by just splitting into the stuff that can be handled without the monster and the stuff that needs to be handled with the monster, and just return outside of this function if the monster is not there. I think that's the better way. Yeah, shouldn't be too hard. Start with type lightning cast, thank you. Also again, this one, that one. Adventurer, forgot this line. And we take E dot. There we go. How much more are there? Oh boy. Oh boy. That's quite a bit of ifs. Type. Oh boy. Damage received. And is monster should be false in this case. E maps to. Why did I rename it in this case? No idea. Yeah. Okay, not sure why I changed the pattern there. Probably because it was one of the very first ones that we ever added. That wasn't even one way. Oh, look, would you look at that? I made a mistake here as well. This one probably needs to have damage received and monster true. Oh. Yeah, and this is monster. Then I will just take this here. Put it to the top, push it to the limit, so that they are next to each other. So one is true, one is false. Next, save, and maybe we stage in the meantime. ES pattern. What could be the benefits of doing it this way? I mean, it's fairly descriptive. We also have like exhaustive checks, exhaustiveness checks, which is nice. Not sure how extensive extensible it will be. So hopefully we will never get into the bad situation where we have to completely change everything back. Yeah. That would really suck. But yeah, we will see. Nope. Oh, interesting case. How do we make an OR? E maps to. How do we make an OR? Match with. Oh, we also have an when. When? Additional conditions the input must satisfy for the handlet to be called. Oh, interesting. So we could do something like, although it will just get longer. Do we do that? With pattern when. pattern, comma, the function, okay. Not or Boolean. So that's our condition. Right there. He is now unknown. Why? And the handler. Oh, it's Sherlock. Okay. Good. Sherlock sitting on. Oh, another Sherlock. Yeah. With patterns. How do we use when? The input will match if your guard function returns a true value. Okay. Should just have used Boolean here instead of true, I think. Truly just makes it more complicated. So I think this should work, right? With pattern, then handler. With pattern. Here's no fire kind. Also fire. But it says possibly undefined down there. So this condition obviously does not propagate or narrow down the type down there, which makes sense that it doesn't work. Also. Well, I guess that's just the way it is, baby. Alright. Just stick to the if something. I think we also saw how to do other patterns by just doing this. Here party cast, comma, and type text. So it will match all three of them. Not sure how. Whatever. It's basically another library just to have ifs. So there's got to be a more proper value that we get from using this. Maybe our use case is too simple. That's also received heal. In that case, oops. E maps to comma, E maps to what he says. Next, with type protect cast, that case, or event again, we map it to something, we close the bracket. And we need to use E. I don't know. With, yeah, monster killed, perfect, thank you. Then do this fun stuff.
and then dot width type level up. Then we take e map to push. Alright. Dot exhaustive. How does that actually work? Read the documentation. Exhaustive. Runs the pattern matching expression and returns its result. It also enables exhaustiveness checking. Sure at compile time that we have handled all possible cases. How does it know that? Oh, would you look at that? Apparently we have received protected cast not handled. Receive. Because we're just calling it right there. Apparently. Okay. Why do we do it like this? I don't remember. Wait. Protect cast. Oh, that's wrong, right? We have protect cast up there. Oh, that's actually a bug. Nice. So that's one thing that we get out of there. The exhaustiveness check actually revealed that we have protect cast twice inside of here. But what we actually wanted is received protect cast like so to call it on there. And the other one being party killed. Dot with type party killed. In that case, I don't know, do nothing right now. To show game over screen. I sure hope we never die. Hey, we fixed actually a type bug. Like that. Very nice. Very nice. So, what do you think, friends? How does this compare to the previous version, where we had just if conditions? So, stage everything, and then we look at the complete diff. Yeah. So earlier we had if event or type monster appeared, then do this. Here we have match event with type monster appeared, and then call this function. Let me just add the render right there for consistency. Yeah, all of them have parentheses. So I think it's nicer. Let me know there in the chat. I'm very, very curious about what you think so far. We did find one bug, which is good. Which there is no way for TypeScript to know in the other one, I think. Yeah, I don't think there is. Except we return from everyone. And then maybe it would narrow down the type. Maybe, but I'm not 100% sure whether it would. So that's one thing, at least. Interesting framework. What else is there? So Unfortunately, the when condition didn't quite work because it does not narrow down our global this.monster well enough. That's a bummer. Yeah. Otherwise, we could have at least. But we didn't. We wouldn't really get rid of this, but at least somewhat. But can if we wanted to. Say first of all we do a refactor here. Use TS pattern. Try TS pattern for event. So, and one thing that we can do is go down, bottom of the sea. We do unfortunately lose this exhaustiveness. If I do it like that. And like that, I mean the following. And just take this condition, put it in front of the matching, and then now we take everything that has this if condition. Yeah, but I don't think it's what. Well, let's just for the lols look at it. What would it be like? Something like this instead. Then we would remove this one and that one and that one. Oh, why not TypeScript? Object is possibly undefined. No, it isn't. If not monster, return TypeScript. Because it's the callback, huh? Is that the reason? Why is this not narrowed down? Is it because it's in a callback? And TypeScript cannot tell when this callback gets called. Well, at the very least, it removes our idea of getting rid of this. In that case, however, we can use exhausted. Just check. Nice. Yeah, so very, very simple API. Basically, you just have match something with give it all the callbacks that you want. I like it. And we also have an otherwise. Alternatively, you can use otherwise, which takes in a handler function returning a default value. Okay. Switching several patterns. Sim knows switch statements allow handling several cases with the same code block. Yeah. We did that as well, right? We have one case in here. They give as an example, they have matched the name with, if it's a text, a span, or a paragraph, then return text. If it's a button or a button, then return button. Otherwise, just return the name itself. Okay. Yeah, so they're writing a fairly complex Well, you could rewrite this one in a way, right? It's a fairly simple one, right? Could just do this. Next. Next. Button, and then say something like my matcher. Although you do repeat a lot, do repeat text, and if this becomes longer, here you just have to add another array entry essentially. Here you have to add another row which again says text. Then you would do something like sanitize 2 name string matcher add position name or just the name, which is the otherwise case. This one is however quite cryptic, while this one is fairly expressive. As soon as you know that you can have multiple, like an overload, but like a list of patterns that you match with. What else do we have? Maybe I shouldn't read from the bottom, but from they have state reducer here, status, idle, loading, success, error. These have different interfaces again. And then they get the state and some events. Pretty much what we are doing. Pretty much. They do use state and event like so. Ah, okay. I don't think we can use this pattern either, because TypeScript still can narrow down that monsters. Oh wait, it can. It can. If we want to make that one work, you would have to use a slightly different syntax, but let's say this dot monster right here. And then, so, and then here we take E as the first entry. Oh no, that does something different. E is an I event or monster. Is that right? Or is it just because we have TypeScript errors and it can't properly narrow down the type? No, it's actually an I event or monster. Why is that? They do provide the type here, but that shouldn't change the runtime, right? They do, however, provide a separate one. We would have to write something like this. No. E. It doesn't work. We give it an I event or type of this dot mod, and we return point. Hey, now it works. Do we have to do this? Yes.
Yeah, the monster pattern is undefined. Interesting. This shouldn't change the adding the type here shouldn't change the runtime, right? I think we need to use something like as const right there. See? Yeah. I think what happened here is that if we do not provide this, it considers this array not as a tuple, like in the within the first slot or the 0 slot, you have event, and in the first slot you have this dot monster or monster. Instead, TypeScript just thinks it's a event or monster array. So if we take this one and we just say const r, here you see that it's TypeScript thinks now this, or it does a union instead by default. What we want is using as const, and that makes it a tuple, which means there's an I event at the first position and a monster at the second, or undefined at the second position. So it's const right here, and then now we have the E down here being ambushed object. Problem is that this is more complicated than just asking if not this dot monster is returned. This makes it fairly complicated to be. So let's revert all of that. Just throw everything away. But it's still nice that there's something like that out there. Yeah, match. Select. Where do they do that? Yep. Use the p.select function. Let's extract a piece of your input value and inject it into your handler. Oh, interesting. That type saved? So here they pick out the subproperty and then they get passed. The subproperty error gets passed into the function all of a sudden. Interesting. Interesting. That's useful. That sounds useful, right? For example, we can here we just want the target, so we could do something like target colon p.select, and we probably have to import. Can we just say select? Where do they import p? Patterns, where are you? There you are. P. So, and now E becomes a string, which is the target now. We could use target right there instead. Interesting. So when you have a very nested object, this becomes much more useful. In this case, well, calling e.target is not that terrible, but still very interesting. Very interesting. Yeah. And it has the right type, most importantly. Here it's matching anything that is not loading on the status. When. Oh wow. When the time is greater than this one, then cancel. Interesting. Very fun stuff.
do they call the p.when? Oh, we can also use a wildcard, which is what I did with the when we had the event and the monster here. I did match on this one, which I think should work because everything matches the empty object. So every object except undefined matches the empty. Oh, that would actually not have triggered this if the monster is undefined. Interesting. Interesting. TypeScript would still not narrow down the type, unfortunately. But yeah. It would narrow it down if we used the monster that we got from the parameter instead of using this dot monster. Wildcard. Definiteness checks pop up, and then we're at the very interesting. Very interesting. Cool to see that there are like these kind of projects out there. We even have a union. What is that? p.union pattern. Lets you test several patterns and it will match if one of these patterns does. It's particularly handy when you want to handle some sort of union type in the calling branch. Ah, that makes this one. That would be an alternative to this one. So we could use p.union right here and provide instead a list of these ones. P.party. Is it small union? P.party. Guest and protect guest. That would be identical in this case. And it's still type safe. Wow. Would you look at that? There's gotta be some magic inside of there. Like, I mean, some real TypeScript. No, real is probably not some advanced TypeScript. That's probably the word that I'm looking for. Let me do this, and now it should still narrow down the type, and it does indeed. Just make sure that it actually did pass the code right here, or compile the code right there, because there was an error down here. Interesting. You can also have intersections. They must match all subtypes or subpatterns. Must, for example, be a p instance of a specific class of, and have a foobar property. Either infer, lets you infer a type of value, type of oops. P dot. Oh. Interesting. Would you look at that? They're doing validation here. They're doing a basic validation using the pattern matching. Very interesting. And it's much smaller. If you would write this in class, for example, class validator, is a library that is often quoted together with NestJS, or at least this clone of it. Oh wait, NestJS I? What does the I mean? It's not the real NestJS. But this one. Here you would have you define a complete class, then you would still have to duplicate from res.json into the class and propagate everything, and then call the validate function, like down here. So this one is like, whoa, it's so simple. Very intriguing. I want to use that at some point. Let's use that at some point. Pattern is a type of all possible patterns for generic type T. Wow, that definitely takes some compute time. Because that's like exponential in the number of properties and subtypes. That takes a lot of... It's basically the power set, if you've heard of it, in math. It's a set of all subsets that you can take from a given set, including the set itself and the empty set. So this one, pretty much the same, but from instead you're considering this as a type, as a set then. Interesting. This takes compute time. I assure you. This one is highly exponential. But very intriguing library. I like it. This is TS pattern. Interesting. There are some cool ideas that you can do with this. I'm most intrigued about the idea for validation. If you just write a patch and then you have like just write a couple of lines of code and then you have the matching, the validation done. That's very nice. I don't think we have any changes that I actually want to commit, but we're at 1.5 hours, hour and 47 minutes now. Thank you so much for joining. We added lightning magic. Let's look at it once more. What we did actually, and after that we did a lot of death ray. Very nice. So we done that. Factor T was just for our list. Refactor / try TS pattern. Oops. There we go. So I thank you so much for joining. This was the TypeScript Tea Time with your host Mirko. Hope you had a great time. I definitely did. And hope to see you next time. Regular times are Wednesday, 18 o'clock Central European summertime. When will the summertime change? It should still be October, so it's still some time with the fine with the summertime. For more TypeScript action. See you around. Bye bye. Have a good one.